All right, so in this video, we are going to do a complete review of chapter 2.3, which is factoring polynomials. Now, majority of the questions we do here are going to be very similar to grade 10 factoring. It's a lot of review of grade 10 factoring, and then it gets a bit more difficult. There are a few added difficulties in the same methods, but for the most part, it's the same methods. So I'm going to do about 20 questions over here that are all slightly different. And if you know how to do all these 20 questions, you should pretty much be prepared to factor any grade 11 question in this chapter. I'm going to start with the first question, which is x squared plus 6x minus 27. So this is a simple trinomial. This is just a grade 10 question. We're using our man method over here. So what multiplies to negative 27 and adds to 6? You want to think of two numbers. So I always think of my multiples first. I know that 9 times 3 is 27, and now I have to make one of these two numbers negative to get it to negative 27. If I look at my addition is positive 6, which means my bigger number has to be positive. So my two numbers are 9 and negative 3. 9 times negative 3 is negative 27. 9 plus negative 3 is positive 6. So my solution here is just x plus 9 times x minus 3. That's how you do a simple trinomial. Second question is 36x squared minus 49. So again, this is just a simple difference of squares question from grade 10. Both these terms are square rootable, and the sign is a negative in the middle, which means we can do difference of squares. So for difference of squares, you just want to square root the first term. So square root of 36x squared is just 6x. Put a plus sign. Square root of 49 is 7. And then the second factor is the same, except we change the sign to a negative. Third question is 4a squared plus 20a plus 25. Now this looks like a complex trinomial, and you can do it using a complex trinomial method. But this also looks like a perfect square because the first term is square rootable, the last term is square rootable. We're going to try perfect square over here. I'm going to square root my first term, which is just 2a. Going to take the sign from the middle term, so plus. Going to square root my last term, which is 5, and then I'm going to put a square outside of the bracket. Now for perfect square, you always have to do a little check. You have to multiply these two terms and then multiply that by 2. So 2a times 5 is 10a. 10a times 2 is 20a. That gives me my middle term, which means the solution is correct. If it didn't work and then multiplication didn't equal to this, then you would have to do man for a complex trinomial, which is basically going to be the fourth question over here. So fourth question is 6a squared minus a minus 2. This is now a complex trinomial, still grade 10 math, but we have an a value over here in the front, 6. I'm going to do a second man method for this question. My m is my first number times my last number. So 6 times negative 2 is negative 12. My a is my middle term over here, which is negative 1. So my two numbers, one multiplies to negative 12 and adds to negative 1. It's negative 4 and positive 3. Now I have to break down the middle term into these two numbers. So I'm going to rewrite this as 6a squared minus 4a plus 3a minus 2. I basically rewrote the equation, but I changed the middle term into two terms using my two numbers. And now I'll factor by grouping. My common factor over here between these two is 2a. I'm left with 3a minus 2. A common factor between these two is just 1. I'm left with 3a minus 2. I'll common factor out this bracket. I'm just left with the outsides, which is 2a plus 1. Okay, so that's all grade 10 math. Basically, your 4 different factoring methods: simple trinomial, difference of squares, perfect square, complex trinomial. Now we're going to get into the next type of question, which again is still grade 10 level. So we have xz plus yz minus xb minus yb. So anytime you have 4 terms, you want to try grouping down the middle to begin with and see if that works. A common factor between these two is z, and I'm left with x plus y. My common factor between these two is negative b, and I'm left with x plus y. My brackets match. I know this is the right step. I'm going to common factor out the x plus y, and I'm just left with z minus b, and that's my final solution. So again, that's just grade 10 math over there. You should know that from the previous year. Coming to the next question, this is the first grade 11 question that we're going to do that you might not have seen in grade 10. At least most classes will not have seen this. So we have x squared plus 2x plus 1 minus y squared. So again, you want to group this in the middle. But if I common factor out x over here, I'm left with x plus 2. And here there's no common factor, 1 minus y squared. And if I notice my brackets don't match. If your brackets don't match, it means this is not the right way to do it. Technically, you shouldn't even write that down on paper. You should just do that mentally. If you common factor, you can tell these two won't match. So that means we have to factor and group it in a slightly different way. If we can't group down the middle, we need to group 3 terms together. So either the first 3 terms or the last 3 terms, or maybe even mix up the order and then find 3 terms that group. But if you look at this question, you can easily tell that the first 3 terms group. So if I split it like this, you can easily tell that this is a perfect square over here. So I'm going to perfect square this. That's just x plus 1 squared. And then I have minus y squared. And now I can do difference of squares on this over here. It looks a bit complicated. So what you want to do is you may want to start by saying let a equal to whatever's in the bracket, x plus 1. And then we can rewrite this as a squared minus y squared. This is pretty easy to do difference of squares now. It's just a plus y times a minus y. And then you want to replace the a's back with x plus 1 plus y times x plus 1 minus y. And then you want to try and combine like terms, but in this case, it's not possible. So this is my final solution. So that's how you group when you're grouping 3 terms together and then having 1 term separate. And you don't necessarily have to group around the middle like in grade 10 math. Let's go to the 7th question, which is pretty similar to the one we just did. It's a squared minus b squared minus 10b minus 25. Now, if I look at this question and I try to group in the middle, I can tell that my common factors are not going to match. The brackets will not match if I common factor. So I now have to group 3 terms together. And for this one, I can tell that these 3 terms are very similar. They're going to make a perfect square. So I'm going to group these 3 together for this one. Now, the trick in this question is because we have a negative here and it's the last 3 terms, we actually have to start by factoring out just a negative. And it's going to change the signs of all of these. And if you don't do this step, you'll get the wrong final solution. Once you factor out the negative, you can perfect square this over here. So that's just b plus 5 squared. Now I can do difference of squares on this, but before I do that, I want to just do a substitution to make my life a bit easier. So let x equals to b plus 5. Then I'll rewrite the equation as a squared minus x squared. I'll do difference of squares, which is a plus x times a minus x. And now I'll replace my x's with b plus 5. So over here, we just have a plus sign, so I can just straight away write b plus 5. Over here, you want to be more careful because if I have a negative sign, I need to put the b plus 5 in a bracket and then distribute the negative into the bracket. And again, if you don't do that, you'll get the wrong solution. So this turns into a minus b minus 5. And again, there's no like terms to combine. So that is basically my final solution. So now we've learned some grade 11 grouping methods, factoring by grouping methods, slightly different from grade 10. We'll go to our next question, which again is pretty simple, I would say. Probably can do it on the same page, actually. I'm just going to squeeze down here. So this is again grade 10 math. If you have something like 4a squared minus 4a cubed minus 6a squared plus 2a, this is pretty simple. This is what we've done in grade 10. It's just a common factor. Over here, my common factor is going to be 2a, and I'll be left with 2a squared minus 3a plus 1. Now, in the bracket, I have a complex trinomial, so I'm going to do my man method. My m is 2 times 1, which is 2. My a is -3. So my two numbers are -2 and -1. So now I'll actually use a square bracket because I'm going to have double brackets pretty soon. I'll split this -3a into -2a minus a. And then I'll factor this by grouping in the middle. So when it's complex trinomials, you're always grouping in the middle. So this is 2a, a minus 1. And here my common factor is -1. This becomes a minus 1. And I can write my final solution. I'll just write it here. So you have the 2a at the start. And we're common factoring out a minus 1. And we're left with 2a minus 1. So this one is a combination of common factor and complex trinomials, which again, you should have learned in grade 10. So nothing really new in that question. Next question is, again, grade 10 math, just review from grade 10. We have 3a squared, a cube b squared minus 9a squared b4 plus 3a b cubed. So again, this is grade 10 math. We just want to common factor this over here. For the numbers, my largest common factor is 3. For the a terms, my largest common factor is a. And for the b terms, my largest common factor is b squared. Basically, you're taking the lowest of each term as a common factor. If I divide 3a cubed b squared by 3ab squared, 3 divided by 3 is just 1, so I don't need to write that. A cubed divided by a is a squared, and b squared divided by b squared is 1, so I don't need that. -9 divided by 3 is -3. A squared divided by a is a. b4 divided by b squared is b squared. And then 3 divided by 3 is 1. A divided by a is 1. B cubed divided by b squared is b. And now this is just my final solution because this does not represent a simple or complex trinomial because the first term and last term have to have squares, and then you just have to have regular terms in the middle. So in this case, this is just my final solution. Okay, next type of question. Again, this is, maybe you don't see this question in grade 10, but technically it can be given in grade 10. So we have x squared times x plus 1 minus 5x times x plus 1 plus 6 times x plus 1. So in this question here, the first thing you want to do is you just want to common factor out the x plus 1 from everything. And we'll just be left with the outsides, which is x squared minus 5x plus 6. Now we can factor this with our man method. So what multiplies to 6 and adds to -5? My two numbers will be -2 and -3. It's a simple trinomial, so I can just write my solution instantly. It's just x minus 2, x minus 3, and this is my final solution. Now, sometimes you can also get a question like this, for example, 5x times 2 minus x plus 4x times 2x minus 5 minus 3x minus 4. So if none of the brackets match, you actually have to multiply each of these terms into the brackets and then factor after. So let's do that. 5x times 2 is 10x. 5x times negative x is negative 5x squared. That's going to be plus 8x squared minus 20x. It's going to be negative 3x plus 4. Then you want to combine like terms. I'll do the x squares first. So that's just 3x squared. 10x minus 20x minus 3x. That's negative 13x. Then I only have one constant plus 4. Now we can try to factor this. It's a complex trinomial. So what multiplies to 12 and adds to negative 13? It's just negative 12 and negative 1. So I'll break down my middle terms into negative 12x minus x plus 4. I'll factor by grouping. So common factor here is 3x, x minus 4. Common factor here is negative 1, x minus 4. And then my final solution is x minus 4 times 3x minus 1. All right, next question is going to be kind of similar. Again, you could potentially see this in grade 10, but it's not that common. So if we look at this question over here, the brackets, they don't match exactly the same, but they look kind of similar. And if you want to make these brackets the same, x minus 3 and 3 minus x, if they're brackets like this and they have a negative sign, you have to start by factoring a negative out of one of the brackets. So I'm going to factor a negative out here. This becomes negative 7. And then this bracket is going to switch to x minus 3 because the x will become positive, the 3 will become negative, and then I just switch the order. Now you can just common factor out x minus 3. You're left with 2x minus 7. So not a difficult question, but you definitely have to know that step. A similar question you could get is you could get a question like this: 2x times x plus 3 plus 7 times 3 plus x. Again, this is a trick question because the signs are now a plus. X plus 3 is literally the same as 3 plus x. So you could start by just rewriting this the exact same, but just switching the order here because there's actually no difference. Don't switch the sign on the outside. We're not factoring anything here. Or you could just write the final solution instantly as well, because technically you can go straight from the first step to this step. Next question is going to be almost done here. Probably have like 3 or 4 more questions left. It's x to the power of 8 minus 1. So this question here can be done using difference of squares. We're going to square root this bracket. So that's x4 minus or plus 1, then x4 minus 1. Now x4 plus 1 cannot be factored by difference of squares because you need a negative sign. So we'll write this the same. This one can be factored again by difference of squares, just x squared plus 1 times x squared minus 1. Looking at this again, the first 2 brackets cannot be factored, so I'll write them the exact same, but this can be factored by difference of squares again. It's just x plus 1 times x minus 1. Next question is negative x squared y squared plus 81. Now this question can be done in a couple of ways. You can either move the 81 to the front, and that way the negative sign is going to be in the middle, or you can start by factoring out a negative, and I'll do it this way. there are multiple possible solutions for this one. Now I can just do difference of squares in the middle over here. The square root of x squared y squared is just xy. Square root of 81 is just 9. And then same thing with a negative sign. I'll grab another sheet. All right, next question is 9 times x minus 1 squared minus 25. Now this is a difference of squares question. Some people might be tempted to expand this all out and do it and then combine like terms and factor, but that's the long way of doing it. You can actually do this by difference of squares because both these terms are square rootable, but it's a bit complicated. So let's do a substitution first. Let a equal to x minus 1. Then I'll rewrite this as 9a squared minus 25. And then I'll factor this by difference of squares. So 3a plus 5 times 3a minus 5. Then I'll resubstitute my a back as x minus 1. 3 times x minus 1 plus 5. 3 times x minus 1 minus 5. And now I'll expand this 3 into the bracket. So 3x minus 3 plus 5. 3x minus 3 minus 5. And then I'll combine like terms because it's possible in these two brackets. So 3x, negative 3 plus 5 is plus 2. And here it's 3x minus 8. And now that's my final solution. Next question is 3a squared minus 27 2 minus a squared. So again, this one is just a difference of squares. Again, you can square root the first term and the last term, but actually you cannot square root 3 and 27, but you can actually common factor out a 3 over here. I'm going to start by common factoring out a 3. A squared minus 9, 2 minus a squared. And now you can square root these two terms. So now we can do difference of squares. But to make my life a bit easier, let me do a substitution first. Let x equal to 2 minus a. So I have 3 times a squared minus 9x squared. Can do difference of squares on this now. So that's a plus 3a, a plus 3x times a minus 3x. And now I'll replace the x back with 2 minus a. I'll distribute this 3 into the brackets for both of them, the 3 and the negative 3. And then I'll combine like terms in both brackets. So a minus 3a is negative 2a. And here a plus 3a is 4a. Now, usually this would be the final solution, but what you notice here is you can actually common factor more out of both these brackets. I can common factor out a 2 from this bracket. So if I common factor out a 2, this becomes 6. This is going to become 3 minus a. Then I can common factor another 2 out of this bracket. So the front is going to become 12 because 6 times 2 is 12. And over here, I'm left with 2a minus 3. And now this is my final solution. We're going to do one last question. This one is going to be an extremely difficult one. Although maybe I can do a slightly easier one before that. Okay, I'll do 2 more questions. They're probably the 2 hardest ones. First one is not too bad, I don't think so at least. So for this one over here, I'm going to group it in the middle to try off at least. My common factor here is x squared, and I'm left with x plus 1. Over here, my common factor is negative 1. I'm left with x plus 1. And I can common factor out x plus 1, and I'm left with x squared minus 1. Then I can common factor this by difference, I mean, not common factor, difference of squares that bracket. So that's x plus 1 times x minus 1. Since I have two x minus 1s, I can just simplify it by writing x plus 1 squared times x minus 1. So that one, again, is not too difficult, but definitely a good question, one you should know. This last question here that I'm going to do is going to be an extremely difficult one. And if you're aiming for 90s in your test, this is the type of question you want to know how to solve, because if it does show up, there's only going to be a handful of students that know how to do it in the class. So if I group this in the middle and I common factor 2a out here, I'll be left with a plus 5. And over here, I could switch the order and common factor out, but the brackets will not match because there's going to be an a left in the bracket here, there's going to be a b left in the bracket here, which means that that doesn't work, factoring down the middle. If I try to factor these three terms don't go together because this has a, and this has a b, so that's not going to work. If I factor these three terms together, that's also not going to work because it has a, but these two have b terms. So how do I do this? Well, I'm going to move this term over here. And now if I look at this, it might be easier to factor by grouping because I have AB and then AB. So that's another possibility for the order that we haven't seen before. I'm going to factor out a 2 over here. And I'm left with a square minus b square. Over here, I'm going to factor out a 10, and I'm left with a plus b. The problem right now is the brackets don't match. But what you still notice is this can be factored further by difference of squares. So I'm going to factor this by difference of squares. It's just going to be a plus b times a minus b. And now what I notice is this bracket and this bracket do match. So I know I'm on the right track. I'm going to common factor out a plus b. I'm left with 2 times a minus b plus 10. Then I just want to multiply this 2 into the bracket. That's 2a minus 2b plus 10. And then I can common factor 2 out of this bracket. And that is my final solution for this one. So like I said, bonus question at the end, an extra difficult one. If you're aiming for 90s in your test, you want to know how to do that one.